Hello everyone. Let us solve the following. In triangle ABC and triangle XYZ, if angle A and angle X are acute angles such that cos A is equal to cos X, then show that angle A is equal to angle X. Okay? Right. So what is given actually? There are two right angle triangles. Okay. And that is triangle ABC and triangle XYZ. Let us assume in the triangle ABC, the right angle is at B, and in triangle XYZ, the right angle is at Y. Okay. Obviously, in the triangle ABC, AC is the hypotenuse, and in triangle XYZ, XZ is the hypotenuse. Okay. These are the basic rules of a right angle triangle that we know very much. Okay. And here what is given? Angle A and angle X, both are acute angles. Okay. And cos A is equal to cos X. One more point is given about these two triangles. Right. So now let us consider first triangle ABC. We have already known that the right angle is at angle B. Angle B is right angle in the triangle ABC. Okay, right. So as A is acute angle, what can we write? Cos A is equal to adjacent side to A by hypotenuse. So we have already discussed here. So if A is a acute angle and the adjacent side to A is nothing but AB, hypotenuse is AC. So how can we write that? Cos A is equal to AB by AC. Of course, BC is the opposite side, but we have been given only cos A. So we are talking about adjacent side to A by hypotenuse. I think this is clear for you, right? Now we are taking triangle XYZ. So again, the right angle is at Y and X is the acute angle. And one more point is given, cos X. Cos X is nothing but adjacent side to X by hypotenuse. Okay, right. Adjacent side to X is nothing but XY and hypotenuse is nothing but XZ. Okay, just we have applied cos A in triangle ABC and cos X in triangle XYZ. It is given in the problem only. Okay, now, so what is given? Cos A is equal to cos X, right? So AB by AC is equal to XY by XZ. Just we are equaling. Cos A is equal to cos X, it is given in the sum, right? So this ratio implies that the corresponding adjacent side and the hypotenuse of two right angle triangles are proportional. So here in the triangle ABC, AB is the adjacent side to A and AC is the hypotenuse of the triangle. In the same manner, in triangle XYZ, XY is the adjacent side to X and XZ is the hypotenuse. So that we are implying, what does it imply? It implies is nothing, it implies in both the right angle triangles, the adjacent side and hypotenuse of those two right angles or proportional. Okay, so let us denote it with a constant of proportionality. Let us assume it as k. Okay, constant. It is nothing but a constant. So what can we write? AB by AC is equal to XY by XZ is equal to k. It is nothing but the proportionality constant. So AB by AC is equal to XY by XZ is equal to k. Okay, so just I'm transposing the terms for simplification. So with this equation, with the help of this equation, what can we write? Just transposing. So AB by AC is equal to XY by XZ. Just I brought this term here. That means AB by XY is equal to AC by XZ. That is nothing but K. So we can write AB by XY is equal to K and AC by XZ is equal to K. So AB is equal to K into XY and AC is equal to K into XZ. Okay, right. Now let us find the third side in triangle ABC. because we have found already AB, the adjacent side to A, and AC, the hypotenuse. Now opposite side is there, no BC. We are just for calculating it. So how can we calculate? By using simply the Pythagoras theorem. So what is Pythagoras theorem? Pythagoras theorem is nothing but in a right angle triangle, the hypotenuse square is equal to side square plus side square. Yes or no? So here what can we write? AB square plus BC square is equal to AC square, where AB is one side and BC is one side and AC is the hypotenuse. Of course, AB is the adjacent side to A and BC is the opposite side to A and AC is the hypotenuse. These are all the technical terms that we must use. Okay, so BC square is equal to AC square minus AB square. BC square is equal to AC square minus AB square. Just I transpose the term here. That's it. So BC square is equal to AC square minus AB square. But what did we calculate here? AB is equal to K into XY and AC is equal to K into XZ. Okay. So just I am substituting those values there. Right? Now, by substituting the values, BC square becomes K into XZ whole square minus K into XY whole square. So further simplification, BC square is equal to K square into XZ square minus K square into XY whole square. Of course, XZ whole square, XY whole square. Right. So BC square is equal to K square common. That's why XZ whole square minus XY whole square. Right. So from the triangle XYZ, if you take XZ square is nothing but the hypotenuse square, and XY square is nothing but the adjacent side square. Yes or no? So adjacent side hypotenuse minus hypotenuse square minus one side square is nothing but the other side square. This is also Pythagoras theorem. Okay, so triangle in triangle A XYZ, what can we write? YZ square is equal to XZ square minus XY square. That is there here. So what can we write? BC square is equal to square A square into YZ square. Okay, so BC is nothing but K into YZ. Okay, square root of K square YZ square. If you take BC is nothing but K into YZ. Again, I am transposing the term here. So what can we write here? BC by YZ is equal to K. We can write simply. So here when we compared cos A is equal to cos B, what did we get? AC by XZ is equal to K and AB by XY is equal to K. Now, after calculating the third side, what did we get? BC by YZ is equal to K. Okay, so clearly we can observe one point here. What is that point? The ratios of three corresponding sides are equal. Here we have two triangles, triangle ABC and triangle XYZ. When we observe clearly the three corresponding sides, okay, the ratios of the three corresponding sides, they are equal. They are equal to K. It's a proportionality constant. Ratios of all three corresponding sides are equal. The two triangles are similar by side similarity criteria. Okay, so side similarity criteria tells us that triangle ABC is similar to triangle XYZ. Okay, so as triangle ABC and triangle XYZ are similar, what can we write? The corresponding angles of those two triangles are also equal. Okay, so those two triangles, let us take those two triangles once again. Okay, what are these two triangles? Triangle ABC and triangle XYZ. We have proved that triangle ABC is similar to triangle XYZ. Yes or no? So, as both are similar, we can say that the corresponding angles are equal. It is clear that angle B is equal to angle Y because both are right angles. So what is the corresponding angle of A? It is nothing but X in XYZ. Okay, so we can clearly say that angle A is equal to angle X. Okay, first we proved that triangle ABC is a similar triangle to triangle XYZ. By taking that criteria, we have proved that angle A is equal to angle X. So